Hello everyone. Today I'm going to show you how to upload a Docker image inside a local Kubernetes cluster. To begin with, I have created a sample Spring Boot application. So as you can see on my screen, I have opened IntelliJ and I imported the Spring Boot application into it. So we start with the main application file. We have named it as image deploy KTS application. This particular project has been generated using start.spring.io. So it is very handy tool. I will recommend whenever you are going to start your Spring Boot project, always use that website. All right, so let's move ahead. We have another class called as say my name, which has one get mapping REST API expose. It accepts a name as a request parameter, and in fact, it returns that same name with a hello message greeting. It's quite simple. Okay, let's go ahead and try to build this application using Docker. So I will head over to the terminal and I will type Docker build. I'll give a name to this. Let's call it as KTS load demo. And I'm going to give a tag as plain. And the location is the current directory. So depending upon whether the Docker image, the base image has been cached in your local machine or not, it will take a time. In my case, the base image is already available inside the cache, and that's why it is executed fast. You can see that we are making use of the Eclipse tamarind. I will show you the image which is being used. Let me head over to the Docker file. So this is the image that we are using right now. In fact, it's a multi-stage build that we have performed. So initially we are performing a build using the Maven image. Once all the packages are generated, we go ahead, we use the base image as Tamarind 21 GRE, and we copy the jar file which is generated inside the base Maven image into our Eclipse Tamarind. And finally, we execute the Java jar file using java-jar command. Sounds pretty simple. Let's go ahead and see this image. So I'll fire Docker images and try to see what's the size of this particular file. Okay, you can see that the file has been created and the size of this image is 299 MB. Now there is one thing which we need to check is to find out in case if there are any vulnerabilities present within this image. That's very important from a DevOps point of view. You should always check and verify the images that you're building. So Docker Scout quick view, I will specify the name of the image. So it is k8s-load-demo plain. Now this particular command will take some time. Let's wait for the execution to happen. Cool, the analysis is actually complete and it has reported somewhere around 212 packages inside this Docker image. Along with, there are few vulnerabilities present in this image. You can see that there are 10 medium and 11 low priority vulnerabilities are present. Now, this may not look as risky as it is, because we don't have any critical or high vulnerabilities, but depending upon the base images that you guys are using, the risk could be at a high scale. So now how do we find out the CVEs which are present within this image? So for that, we can simply fire the CVE command. So it is Docker Scout CVEs, specify the name of your image along with the tag and just press enter. This should give you the list of CVEs which are present. You can see that all of those CVEs are listed over here. Now, as a routine practice, you can just go ahead, find out each and every CVE, check the scores which are assigned, if there is any version which is fixed, if there is any new version which is available which can fix this CV, you may have to go ahead and fix it. Now this specifically can become a nightmare if you have too many CVs reported into your base image. Now is there any alternative available? So we have Chainguard, which actually distributes a safe images. They identify the vulnerabilities present within the Docker images, and on a regular basis, they keep on patching these vulnerabilities and make it available to the community. In fact, there are most of the images which are freely available, which community can leverage. In case if you are looking for a specific images, then there is a paid option which is also available. You can simply go to their website and you will find an option to see the existing set of images. So there is products, then go to Chainguard images And inside Chainguard images, you will find a list of images which are available for the various platforms. You can search for any specific image and then you can get a reference of that. Let's go ahead and try to fix our image. In our case, we are using Eclipse Tamarind 21 JRE. Now we can simply replace that with the Chainguard image which is available. Let's go ahead and do that. So I will replace this Eclipse Tamarind to Chainguard slash or Chainguard slash JRE. Let me save that. Okay. And I will go back to the terminal. I'll clear this. I'll fire the docker build command again, but this time I'm going to give a tag name as CG. Let me execute that. You'll see that the build is happening. Again, in my case, this particular image was already cached. In your case, it might take some time when there is a fresh installation is happening. Let's go ahead and try to check the vulnerability report of this particular image. So I'll fire the docker scout command again. Docker scout quick view. This time I'll pass the tag name as CG. Okay, it has already reported there are 68 packages. The package count has gone down drastically. In fact, if you'll see the vulnerability count, it is 0. There are no vulnerabilities which are present. Quite fantastic, hey? Okay, let's go ahead and let's see if we can upload this image into our Kubernetes cluster. To do that, I'm going to make use of a utility called as kind. So I'll fire a command kind create cluster. Let me give a name to this particular cluster as Spring App. Okay, it will take some time. All right, so our kind utility has created a cluster. Let's go ahead and make use of that cluster. So the very first thing that I'm going to do is to upload the image that we had just now created. So to do that, the command is kind load docker-image followed by the name that we want to assign or the name that we have already assigned to our image. So k8s slash load demo followed by the tag name and press enter. It says that no nodes found for cluster kind. Now this is something interesting. While we created the cluster, we gave a name to it as spring-app, and that's the same cluster name that we need to specify when we are loading a Docker image. Let me go ahead and correct the mistake. So at the end, I will say that name is equal to spring-app. Cool, it has started uploading the file inside the custom cluster that we have created. Okay, so our image is now available inside the local Kubernetes cluster. Let's go ahead and try to create an application using the image that we have just created. So to do that, I have already created a Kubernetes YAML file. Inside this, we have a service, k8s Spring service, as well as we have the pod definition done for our application. Okay, let me just go ahead and apply this particular Kubernetes file. I will go back to the terminal and fire kubectl -f. The name of our file is k8s-app-service.yaml file. Let me just check that. Okay, it is YML and I need to apply it. So kubectl followed by apply. Cool, and it has just now created a service. Let's go ahead and check whether our service is available on a given port. So the port that we have exposed is 8080. That's a port that we have exposed on this service as well. Let me go ahead and open the terminal again and use the kubectl command to do a port forwarding. So port forward followed by service, and we need to give a name of the service. So the name of the service is k8s Spring Service. I'll just copy that, paste it over here. And I need to now specify the port which we will use to access this application. So I'm going to make use of 80. Making a mistake. Let me just correct that. Okay. 8080, which is mapped to a same port 8080. Let me press enter, and this should help us to forward a local port 8080 to the service port that we had just created inside the Kubernetes. Okay, so I realized that I made a mistake while creating this Kubernetes YAML definition. So the name of this label should have been Java app, okay, because that's what the label that we have assigned to our pod. Let's go ahead and quickly create our service again. I'll fire the delete command and I will reapply this configuration again. Okay, so the service has been created. Let's go ahead and also execute the port forward command. Okay, this time it is showing that it is now enabled or accessible on 8080 port. Let's go ahead and try to access our REST API. It is available on localhost 8080 followed by hello. And then the name of our parameter is name. I'm going to pass value as carbon writer and it should print a hello message. So congratulations, our REST API is now accessible, which we deployed inside a local Kubernetes cluster. So we learned a pretty good lesson today, how to create our Docker local image and then upload it into the local Kubernetes cluster using the kind utility. But before that, a very important lesson of making sure how to protect your Docker images from critical vulnerabilities. We looked at the Docker scout command, which help us to get the list of critical vulnerabilities. But along with that, to solve those critical vulnerabilities, Chainguard came to our rescue. So I will recommend that you go ahead, check this website, Chainguard.dev, and find out the different options that they are offering for both for open source community as well as for a paid subscription. I hope you must have enjoyed this video. I will see you soon in the next one. Till then, take care and build something.